Hey everyone, and welcome back. Today, we're jumping into a really cool story of AI engineering. It's all about how Google found this hidden flaw in their recommendation systems and came up with a technology called static that made them, and I'm not kidding, almost 1,000 times faster. So let me ask you something. Have you ever been shopping online and you get a recommendation for the perfect item, but when you click, it's sold out? Or you're browsing videos and you get served a breaking news story from 3 days ago? It's super frustrating, right? It feels like such a simple mistake for a super smart AI to be making.
Well, it turns out this isn't just some minor bug. In the AI world, it's actually part of a much bigger issue they call the hallucination problem. This is where the AI literally just makes stuff up. And for the newest generation of AI recommendation engines, it's a massive, massive hurdle.
Okay, so to get why this happens, we have to look at this new method called generative retrieval. Now, think about it like this. Instead of just picking an item from a list, the AI is actually building the recommendation from scratch. It's almost like it's spelling out a unique code, a semantic ID, for every single item, one piece at a time. This is an incredibly powerful way to do things, but it also means the AI can misspell that code, which leads it to recommend something that's not available, or worse, doesn't even exist.
So you're probably thinking, why not just give the AI a set of rules? You know, a simple filter that says, hey, only recommend things that are actually in stock. It sounds so easy, but this is where we slam into a huge technical wall, the accelerator bottleneck. It turns out that the very hardware that makes AI so fast, the GPUs and TPUs, are shockingly bad at this kind of simple, logical check.
So the classic way to solve this is with something called a prefix tree. It's basically a step-by-step checklist, which is logical and straightforward. But here's the conflict. That one-step-at-a-time approach is a complete nightmare for modern AI chips. See, GPUs are built to do millions of things all at once. That's called parallel processing. They hate doing a slow, sequential, one-by-one check. It just grinds everything to a halt.
And here's the nitty-gritty on why it fails so badly. First, memory latency. The prefix tree makes the chip jump all over its memory to find the next piece of information. That is incredibly slow. Imagine trying to read a book by having to run to a different library for every single word. That's kind of what's happening. And second, this whole process just breaks how AI compilers work. They need a fixed map of what they're going to do before they start. This unpredictable step-by-step method just doesn't fly.
So what do you do when the old logical solution is just fundamentally broken? Well, you invent a completely new one. And this is where a brilliant team from Google DeepMind and YouTube comes into the picture. Let's meet the hero of our story, Static.
This quote right here is the heart of the entire idea. Instead of thinking about the problem as a tangled web that you have to navigate one step at a time, the researchers asked a different question. What if we could just reshape that entire web of choices into a single, clean, mathematical object? And that object was a matrix, something computers are exceptionally good at handling. And the process itself is just beautiful in its simplicity. So you start with that complex, tangled web of choices. That's the old prefix tree. Then, Static flattens that whole mess into a perfectly organized grid or matrix. And finally, and this is the key, it makes that matrix sparse. Think of it like taking a giant spreadsheet and just deleting all the empty cells, leaving only the important data. This makes it ridiculously compact and efficient. And what's the end result of all this? Well, what used to be a slow, painful, step-by-step check becomes a single, beautiful calculation, a matrix multiplication. And that is something that modern GPUs and TPUs can do in, quite literally, the blink of an eye. It's a total game changer. Okay, so that's the theory, right? A clever matrix trick. But how did it actually perform in the real world? Well, you might want to brace yourself for some truly jaw-dropping numbers.
Seriously, just take a guess. How much faster do you think this new method is? Are we talking double the speed? 10 times? Maybe 100 times faster?
948 times faster. No, that is not a typo. We're not talking about a small improvement here. This is a nearly 1,000-fold leap in performance. It just completely redefines what's even possible for real-time AI. Just look at this table. The old CPU method, it added over 31 milliseconds of delay. It more than tripled the total processing time. Other methods were still pretty slow, but Static, it adds just 0.033 milliseconds. That's 1/4%. At that speed, the check is basically free. It has almost no cost.
And here's what might be even crazier. All of this incredible speed doesn't come with a huge memory cost. It's super efficient, using only about 90 megabytes of that really precious, high-speed memory for every 1 million items it needs to track. That is just fantastic.
All right, so it's ridiculously fast and efficient. We get it. But what does this actually mean for you and me? Why should we care? Let's talk about how these technical wins actually change the recommendations you see every single day. So this wasn't just some experiment in a lab. Static was deployed on YouTube. They gave it one simple rule: only recommend videos uploaded in the last 7 days. And the results? They were immediate. Views of fresh videos shot up by over 5%, and the overall click-through rate got a nice, measurable bump. The bottom line? It just works. And they tested this at a mind-boggling scale. The system flawlessly handled a constantly changing list of 20 times million videos with 100% compliance. Not a single old video slipped past the filter. That's a level of accuracy and reliability that was just plain impossible before.
But wait, there's another amazing side effect here. Static helped solve what's known as the cold start problem. This is a classic issue where new stuff, a new product, a video from a brand new creator, never gets recommended because the AI has never seen anyone interact with it before. The old result for these new items was literally 0. But with Static, you can actually force the AI to pick from a list of new items, giving them a real fighting chance to get discovered.
All right, we've gone on quite a journey here, from AI hallucinations all the way to sparse matrices. So let's wrap this up and really lock in the most important takeaways from this whole thing.
So let's recap. First, Static is a total game changer because it brilliantly flipped a hardware problem into a hardware-friendly solution. Second, it delivered that mind-blowing 948x speedup with basically 0 overhead. Third, it's been proven at YouTube's massive scale to actually make the user experience better. And finally, it provides a really elegant solution to that nagging cold start problem, helping new content and new creators find an audience.
And that kind of leaves us with one final big question to think about. We've just seen how Static can enforce a simple rule like freshness with incredible efficiency. So what comes next? What other invisible, ultra-fast AI rules are being built right now that are going to quietly shape the products we see, the news we read, and the entire digital world we live in? It's pretty fascinating to think about. Thanks for joining me.